Hi, I'm Ben Staplefeld, one of the founders of New Pig Corporation. We're serious about our role as the leader in leak and spill response. Your training needs led us to produce this and other videos relating to hazmat spill response. Extensive research and planning went into this video called Spill Drill. We hope it becomes an important part of your spill response training program. Let us know what you think. And now, Spill Drill.
Look around. Liquids are everywhere. They have a definite volume, but no form. They're fluid. They flow. Some are harmless. Others are corrosive, reactive, flammable, or toxic. They are lubricants and fuels, paints and coatings, hardeners, degreasers, neutralizers, and acids. Wherever you have liquids, you have the possibility of spills, leaks, or releases. Most reportable spills occur in fixed facilities, factories, laboratories, plants, and mills. In 1 year alone, over 34,000 hazmat incidents were reported to the National Response Center. Over 60% of these spills involve small quantities, fewer than 10 gallons of hazardous liquid. Most people think that spills can't happen to them, but spills can happen at any moment in your facility, and that's why you must practice and be ready to respond. You must drill to be prepared for a spill. You need to know 7 simple steps. If you follow them, you will protect yourself, your fellow employees, and your environment. This is Spill Drill. When a spill occurs, you have to be prepared. Start with familiarizing yourself with the facility's contingency or emergency response plan. You must be aware of the spill potential in your plant. Every minute is critical to keep everyone safe. Since no two incidents are alike, you have to be ready to take quick action. Response to a hazmat spill requires each of these essential steps. Assess the risk. Protect yourself. Stop the source. Confine the spill. Clean up. Decontaminate, and report.
Assessing the risk is a continuous work, not only just to address the level of protection and respiratory protection, but also throughout the cleanup, throughout the decontamination. This is a process that never stops.
The first step, assessing the risk, begins the moment a spill occurs. You must recognize the potential dangers and act immediately. Sometimes, no one is present when a leak occurs. The instant you discover it, you will begin to assess the risk the spill represents. When you notice the spill, ask yourself these questions. What substances are involved? How much liquid has spilled? How dangerous is it? Does it represent risks to life, property, or the environment? It is essential that the spilled substance be identified and any complicating factors recognized. You must recognize what you can and cannot safely do. As you work on spills, things will be changing. The dangers may lessen or they may increase. Risk assessment should be constant. This is very important. But before you take action, make sure you are protected.
The way that you protect yourself is by wearing chemical protective clothing. So if you're going into the hot zone to do some type of a cleanup, you need to wear the correct gloves, the compatible suits. You have to wear the correct respiratory protection. You have to justify air purifying respirators. You have to justify self-contained breathing apparatuses.
Select the right level of personal protective gear depending on the severity of the spill and the chemicals involved. No one kind of suit protects against all hazards. You may simply need goggles, a rubber apron, boots, and gloves. Or maybe you'll need a fully encapsulated chemical suit with flash protection. If you're uncertain, assume the worst and use the highest level of protective gear. Exposure by inhalation is one of the most common injuries suffered by hazmat teams, and one of the most common mistakes is using air purifying respirators instead of a self-contained breathing apparatus. Whatever you use, you have to make sure that it fits right and it's clean, decontaminated, and sanitized after every use. Always use the buddy system. Never handle a spill on your own. In dangerous situations, suit up in groups of 4. You will need radios or other reliable communications between team members. Don't think your safety gear makes you untouchable. Chemicals can penetrate through your suit, boots, or even your goggles. Suits can get punctures, tears, and seam rips. Over time, equipment can degrade from natural wear and tear and improper storage. If chemicals break through any of your protective equipment, leave the spill area immediately. Protect yourself. Choose the right size suit and be careful when you're working. Watch how you bend. Never kneel on rough cement. Avoid rubbing against something that could rupture your suit. Chemical mixtures can change everything. The way they react with each other can make a big difference. If you're unsure of their reaction with each other, assume the worst and dress accordingly. Your eyes are safely covered, but you can't see as well as usual. Your feet are protected, and your body completely shielded, but you can't move easily. And you're often very, very hot. The breathing apparatus makes this even harder. With all these handicaps, you're going to have to be highly responsible, more efficient, and more observant than ever. The time of an actual accident is not the time to fumble with unfamiliar gear or procedures. You must protect yourself and others. Keep people away from a hazmat spill site. The area immediately around the spill is an exclusion zone or hot zone, which no one should enter except protected responders. Surrounding the hot zone is a contamination reduction or warm zone. An access corridor is established through this reduction zone. It should have an inbound and an outbound lane, and it is here that workers and equipment will be decontaminated. The support or cold zone is where the command post is located. If you're dealing with a spilled liquid that vaporizes, you will need to monitor the air. Vapors may be invisible and drift, so the exclusion zone will be much larger. Vapors may be heavier than air and sink and spread, or they may be lighter than air and rise and disperse, or rise and become trapped. You may encounter isolated pockets of vapor. Other questions to ask yourself are, how much liquid is spilled? Which way is it moving? And what's in its path? You must try to keep contaminants out of soil, groundwater, and waterways. These are a lot of steps. That's why you must keep practicing and familiarize yourself with the procedure and equipment. It is critical that you are prepared.
After assessing risk and dressing appropriately for the hazards, you've now contained the spill. But remember, say it's a 55-gallon drum, that spill is still leaking. So we've contained what's spilled, now we've not need to stop the spill. Well, how are you going to do that? Based on your container, whether it's a 55-gallon drum, whether it's a tank car, whether it's a 9,000-gallon tank truck, you're going to stop the leak to prevent that spill from getting larger. The sooner you can stop the leak, the smaller your incident remains and the easier it will be to mitigate.
Stopping the source may be a simple step, such as uprighting a container or rolling a drum so that the leaky side is facing up. You may have to turn a valve or an emergency shutoff. You may have to plug or patch a leak. A temporary repair job with a wooden dowel could do the trick. Self-tapping screws or a special quick-setting epoxy could stop the source of the spill. Contents of a spilled drum can be transferred to a new container. A reusable patch can be applied. Each situation is different. That's why you should familiarize yourself with the options to stop the source.
Confining the spill means that you want to reduce the amount of the fingerprint, the spill, as much as possible. And you do that by different ways, depending on the material. You can dike, you can divert, you can dam, you can neutralize, you can absorb. These are all different types of supplies that you need on hand for you to be able to perform this function.
Confinement means limiting the spill area. The faster you can stop the source, the less liquid you'll have to recover. Generally, the sooner you can confine the spill, the less area you'll have to decontaminate later. For a very small spill, you simply wipe it up. For a larger spill, confinement might mean diking, damming, diverting, or otherwise confining the liquid to keep it from spreading. The key to successful spill response is having the right equipment on hand and knowing how to use that equipment when a spill occurs. Mats, socks, pillows, loose absorbents, booms, even non-absorbent dikes and drain covers can speed containment and response. Spill kits should be designed to suit your specific spill potentials, and spill supplies should be checked and replenished according to a regular schedule. To confine a spill, you generally start at the furthest point. A dam made of absorbent socks effectively stops liquid and at the same time makes the recovery process easier. Be sure to overlap absorbent socks in such a way that the overlap is to the outside of the flow. Otherwise, leakage could occur. It is important that your diking material be heavy enough. A strong liquid flow or large amount of liquid may require a secondary containment line. A non-absorbent dike is heavy, contains the flow, but does not absorb the liquid. As a rule of thumb, a dike's height should be twice the depth of the spill. A dike's base width should be 4 times the depth of the spill. A common mistake is trying to employ a dike too close to a moving spill. Give yourself a little distance. You don't want spilled liquid to reach the dike line before the dike can be finished. Confining the spill is critical to prevent the liquid from spreading to other parts of the facility and keep you and others safe. You must be prepared to confine the spill.
Once I've contained this genie, these hazards, inside of its container, this tells me if it's being released or did I do a 100% plug? Was I successful in plugging the spill? But we've got to make it safe. We've got to open up the area to public. We've got to open up the area back to the workforce. So the way we do that is by cleaning up. How do you clean up? Depending, do you neutralize acids and bases? Do you absorb solvents? Are they polar solvents? Are they non-polar? These are all addressed in the pre-plan. Then you have to take and you have to minimize its cleanup. That's another word for cleanup, minimizing. I need to take all of those contaminated absorbents, all those contaminated pieces of cleaning material and overpack them. Meaning I'm putting them in a garbage can. And it'll sit there in a garbage can that now we can move to a safe area. Maybe your facility has a garbage can or what is called a hazardous waste holding site for a private company or a third party to dispose of it according to the EPA regulations.
After a spill is confined, the cleanup stage begins. Some spills can be vacuumed or absorbed. Be careful not to step in the liquid. Always minimize contamination. There are recommended procedures and guidelines, but usually there isn't just one right way to get the job done. Take overpacking. There's the inverted technique, the roll method, and others. Whichever technique you use, remember, the goal is to prevent the spread of hazmat contamination.
Decontamination is simply put, is just cleaning up. Cleaning up people, cleaning up equipment. How do you do that? Based on your risk assessment, you'll know how to properly clean up.
Decontamination is the removal or neutralizing of hazmat materials that have accumulated on people and equipment. The first step to decontamination is prevention. No one should ever enter a dangerous hazmat spill zone until a decontamination area is ready. You may have to remove and dispose of clothing, or thoroughly scrub and rinse yourself with soap and water, or a chemical neutralizing solution. Decontamination techniques should be practiced so that you are best prepared when a hazmat spill occurs.
What proper reporting does, it not only lets people know what incidents have happened in this country, but it also prepares us for the next incident. We take the information from this spill, we take the lessons learned, and we build an SOP that tries to prevent this from happening again.
Hazmat dangers cannot be ignored. Be certain you follow all local, state, and federal reporting requirements, for there could be penalties for neglecting this. The law also requires annual training for every hazmat spill responder. There are a few other factors you could have to consider. The spill site must be evacuated and safely cordoned off. Check on and off the site to see if someone was affected by the chemical, heat, or vapors. If you find someone, evacuate them through your decontamination and control zone. Look around for other complicated factors, such as open flames, heat or ignition sources, vapors, fumes, ventilation fans, wind direction, open drains, pressurized containers, strange noises, or anything else unusual. Be sure you spill drill. Schedule regular practice drills. Take each drill seriously because it may cost you or your friend a life. When a spill occurs, just remember the 7 steps that you practice in the spill drill. Assess the risk. Protect yourself. Stop the source. Confine the spill. Clean up. Decontaminate. And report. The more practice you have, the better those decisions will be. Hazmat responders have a big responsibility to themselves, their fellow employees, and the community. So don't respond without practice. Be prepared.